Welcome to the project demonstration of weather sensible jackets. So here we are going to use the DHT11, so which can monitor the humidity and temperature inside the jacket. So those who wear this jacket, so the inside temperature and humidity will be monitored continuously by this Arduino Uno board, which we place inside this box, and that particular values will be displayed on the 16:2 LCD screen. So the next step is, if the temperature is above threshold value, in order to make cooling inside the jacket, to provide the cooling for the person, those who wore this jacket. So that will be done by the Peltier plate. That is a thermoelectric plate. So here we place the cooling fan to provide the air inside that, and that cooling fan will get the cooling effect from this below plate. So this was attached to the Peltier plate. So both sides we place the heating and cooling coolants. So the back side will provide the heat and that will be dissipated to the air, and inside the plate will provide the cooling and that will be dissipated inside the total jacket. So this will cooling and heating will be done whenever the inside of the jacket is more temperature than the threshold value. If the temperature inside the jacket is less than the threshold value, then this system will switching the polarity to this thermoelectric plate. By switching the thermoelectric plate polarities, we are going to change the heating and cooling effect automatically. That will be done by our Arduino Uno board only. I will show you that inside the box. So here then this side will go into the heating side, and the heat will be dissipated inside the jacket, and here also the heat will be dissipated, is the cooling side. So the cooling also will be dissipated to the outside. So the main application of the working process of this Peltier plate is, so it will transfer the heat from one side to another side. So then we will show you that the model, right? So here is the Peltier plate. It's a thermoelectric Peltier plate we are going to use in our project. One Peltier plate is used here to transfer the heat from one side to other side. So if we provide the battery power supply to this red as a positive polarity and negative polarity to this black wire, then this name side will provide us the cooling and other side will provide us the heat. So how much of heat was dissipated to the air, parallelly that much of temperature will be decreased to the cooling side. So vice versa, if we change the polarity, so red to the negative and black to the positive, then this side will going to be the heating and this side will become the cooling side. So the main sensitive part for the Peltier plate is, whenever the cooling side was getting cooling, means it is transferring the heat from one side to another side, then we should cool that by using this heat sink. Otherwise the Peltier plate may get damaged. So we need to protect that. It's a very sensitive part while heating other side. And coming to this motherboard, so let us see. This LCD will display the parameter values, and the next inside that we have placed the Arduino Uno board and electromagnetic relays. So there are two relays. So when we switch on the one relay, plus to this side and minus to that side, means cooling this side, heating that side. When the temperature is low inside the jacket, which is a less than our threshold value, then automatically the relay switching will be changed by this Uno board, so that this side is going to be the heating, other side is going to be the cooling one. And below this Arduino Uno we can see the batteries. So there we are using 3.7 volts batteries we are using. So that was 4 batteries were connected in series, so we will get 11.7 volts. So that is the main operating voltage for our Peltier plate. And so the 12 volts is the main input to this Arduino Uno board also. So it will take 12 volts here and provide the 5 volts DC. So when it get the 5 volts DC, it start reading input from this DHT11 sensor. Through these wires, we are going to getting the power supply to the CPU fans as well as to the Peltier plate. And these 3 pins are connected to the DHT11 to get the humidity and temperature values continuously. So here we are using this battery, so which is rechargeable. So this is a buck boost converter. So in order to recharge that battery, just we need to connect the B-type charger over here. So it's very sensitively insert. So B-type charger like this. Right. After inserting that, there is a light indication over here. So when it is turned to blue, then the battery is fully charged. So that's the indication while charging, and once the battery is fully charged, it will turn into the blue light. So after that, you can just disconnect the power supply, and then this is the main on off switch, on off. So I'm just switching on. Right. Switch on the circuit, and a welcome message will be displayed on the LCD screen, and thereafter continuously temperature values will be displayed over here. So we can see that. So now I'm closing this. So wait for some time, then the insert temperature will be getting comes down to right. So you can see that. So it will take a bit seconds of duration only. Right. Okay. So it's keep on decreasing the temperature. When it is temperature is near to 20 degrees centigrade, then automatically it will stops decreasing the temperature. And when it is below 20 degrees, then it will switch the relay circuitry so that we can change the polarity for the Peltier plates, and parallelly we are going to change the heating and cooling system for inside and outside. So based on the weather sensing, this jacket will works as cooling and heating provider for the like persons those who wear this jacket. Right. So it's directly we can place inside the jacket packets. Right.